Let's look at example 1. Determine the average velocity for an object traveling with the following equation from t equals 0 to t equals 2 seconds. V sub t equals 4 plus 3t squared dt. Okay, the average velocity then for this is then going to equal the integral from 0 to 2 of 4 plus 3t squared dt. All of this is going to be divided by 2 minus 0. Okay, well, we take the antiderivative of this equation. So therefore, V average is then going to equal, under a definite integral of 4t plus t cubed plus some constant c. And we're going to evaluate that from 0 to 2. And of course, this is going to be divided by 2, because 2 minus 0 is 2. Well, you know, under a definite integral, the constant c is going to cross off, so we're not going to put that in anymore. So here goes. The V average is then going to equal 4 times 2 plus 2 cubed minus, and I'll put this in brackets to make sure all of this is subtracted, 4 times 0 plus 0 cubed. And this, of course, is divided by 2. Okay, now this, of course, is just 0. And then we have 8 here plus an 8 here, which becomes 16. And then you divide that by 2. V average is going to equal 8 meters per second. And that's how you apply that theorem there. So we're going to deal with speed next for average speed and apply the same principle, but we have to remember we need the absolute value of it. So let's see. Determine the average speed, meters per second, for an object traveling with the following equation from t equals 0 to t equals 6 seconds. Because we're dealing with speed this time, we're going to need to know when this function is 0 so that we can know when the function is positive and when the function is negative. So I'm going to set this equation equal to 0. 0 equals negative 4t plus 8. Well, it looks like t seconds is equal to 2. That's when this function, okay, goes to 0. So this function is positive before 2 seconds and then negative afterwards. Okay, to get the speed average then, we have to separate this into 2 integrals. So average speed, and I'm going to put the average velocity and then put an absolute value for that, is then equal to the integral from 0 to 2 of negative 4t plus 8 dt plus the integral from 2 to 6 of negative 4t plus 8 dt. And then I'm going to absolute value this because we don't want that to be negative. And we're going to divide all of this by 6 minus 0. So we have 2 definite integrals to do. This will be a definite integral from 0 to 2. This will be a definite integral from 2 to 6. Okay, so then V average with an absolute value sign, we'll need to take the absolute, well, we need to take the antiderivative here and the antiderivative here. Okay, so here we go. This is then going to equal the definite integral negative 2t squared plus 8t plus c over the definite integral 0 to 2 plus the absolute value of the definite integral of negative 2t squared plus 8t plus c under a definite integral of 2 to 6, absolute value of that. All of this is going to be divided by number 6. Okay, so then what you'll need to do then is plug in 2 for time there, and then 0 under a definite integral, and subtract those. And over here you need to do likewise. You'll need to put a 2 and a 6 in there, and then make sure that's whatever answer that comes out to be is absolute value. So do a definite integral here and a definite integral here. When you do the definite integral here, you get 8, and the definite integral here under the absolute value is 32, so I'll go plus 32, and then we'll divide this by 6. And the answer comes out to be 6.7 meters per second. So that's how you handle the speed, because remember, speed can't be negative at all. It's always got to be some kind of a positive value. So if we continue with our concepts, there is a difference then between instantaneous speed and average speed, and instantaneous velocity, average velocity, those kind of things. Okay, if you remember from AP Physics 1, whenever you do the instantaneous, it's really a limit. So let's just say velocity instant. Okay, that is the limit of delta x over delta t as delta t approaches 0. So what that ends up being then is the slope of a tangent line drawn to the curve at any point. So let's say I want to have the instantaneous velocity at this position here. So then I just take the slope of it, the tangent line to the curve. Now this will come out to be negative. And what about the instantaneous velocity at this point here? And it could be any time value if you trace down to the x-axis here. Any time value that you pick. It'll be equal to the slope of the tangent line drawn to the curve there. Okay, but remember, if I take the absolute value of the instant, okay, that will equal the instantaneous speed. So I'll abbreviate that instantaneous speed here. So once again, you know, speed is just the absolute value of the velocity. In our next video, we'll look at more examples of our instantaneous speed, velocity, and acceleration, and we'll look at the Fab 5.